Hi, Assalamualaikum and welcome to my video presentation. First of all, I would like to express my gratitude to all who are watching this video, especially to the chairman, panels, professor, associate prof, doctors, ladies and gentlemen. Today, I would like to present my final undergraduate project entitled Lift and Drag Coefficient of Cylinder with Groove in Water Tunnel. Thank you.
This is my slide for my video presentation. Let's proceed to the introduction. First, long time ago, there were so many studies have been made by scientists and engineers on characteristic of flowing fluid on a body. It is important as we want to know and investigate the characteristic of water passing a solid body, whether on air or submerged in water. One of the factors that we need to consider from the situation is the drag reduction. It is become the big topic in this field research. There were several methods have been conducted to study the behavior of the flowing fluid. One of them is by implement groove. What is groove? Groove are one of the method for drag reduction. Many studies has agreed that the application of groove around the circular cylinder is the effective tool to drag reduction. In this study, we will use water tunnel machine to study the fluid motion on submerged bodies in the water. Next, we proceed to the problem statement. In the real-world application, circular cylinders are one of the shapes that have been selected to make a design. For an example, they will design a pipeline that have been placed under the sea in order to transport the water from one point to another point. Several defections could occur due to the wave flow. Due to the issue, in this experiment, we will investigate the effect of circular cylinder with groove on behavior of fluid. The aim of this project is to compare the effect of groove for flow visualization and forces with cylinder and smooth groove. Next, we proceed to the method of drag reduction, which is groove. Groove is the effective tool in the drag reduction. There were so many types of groove, which are U groove, V groove, and rectangular groove. U groove and V groove are the popular one. Previous studies show that U groove is more effective than V groove. Next, the objective of this project is to determine the value of coefficient of drag and coefficient of lift. The second objective is to visualize streamline pattern by using foot die coloring at 5 Hz motor pump frequency. The scope of this project is to use small-scale water tunnel machine that is located at Fluid Laboratory 1 UTM. The angle of attack is 0 degree due to the symmetrical cylinders. And we will use 4 different selected motor pump frequency with unit of Hertz, 25 Hz, 30 Hz, 35 Hz, and 40 Hz. The density of water is 1000 kg per meter cube. And there are three models, which is circular cylinder with three different types of surface. First, full groove surface, half groove surface, and smooth surface. The material of this model is made by Arcalite. Then we proceed to the literature review. From these studies, we want to study the effect of groove on flow pattern around the circular cylinder body. The observation is the application of groove on the circular cylinder surface has influenced the wake flow pattern and also turbulence statistic. Then we proceed to the second studies. From this, we want to study the effect of drag reduction of groove cylinders in the critical Reynolds number region. The results show that the increasing the number of grooves on a cylinder of a given diameter dramatically reduce the critical Reynolds numbers. Next, from this study, we want to make a comparison of the effect of drag coefficient for cylinder with groove and cylinder with smooth surface. The observation that the drag coefficient between V groove and smooth cylinder were the same in the specific Reynolds number range. Then from this study, we want to investigate the behavior of flow fluid around the cylinder based on different type of groove. As the observation, U-groove cylinder were approved by the studies that it is effective than V-groove cylinders on drag reduction. This is the figure for my work planning. This is the flow chart of my project. The figure show overall a flow chart of completing my final year project. First, I updating my research by doing background study. Then I proceed with updating my literature review. And then I determine my final objective and scope. And then I start my experiment by using water tunnel machine that provided by the facilities. I conducting experiment to determine the value of coefficient of drag and lift and also streamline observation. And then I finished collecting all the data and started to do the analyzing and conclusion. Next, we move to the methodology part. The apparatus that I used to conduct the experiment is small-scale water tunnel, circular cylinder models, which are full groove, half groove, and smooth surface, water, food coloring dye, and also desktop computer. From the right image, it is show the water tunnel machine that I use. It consists of 5 component parts with each head tank, test section, tail, pump and piping system, and also speed controller box. Next, this is the specification of small-scale water tunnel. The max parameter of motor pump frequency is 45 Hz, and the angle of attack is 0 degree fixed. And then from the right, it shows the flow rate conversion table. For this project, the selected flow rate are 25 Hz, 30 Hz, 35 Hz, and 40 Hz. Next, we proceed to the image of my circular cylinder models that used in my project. Full groove, half groove, and smooth surface. All these 3 models have the same diameter, length, and also material. The diameter is 4.5 cm and the length is 7.8 cm, and the material of the cylinder is Arcalite. This is the material that I used to conduct the experiment for streamline observation. This is food coloring dye, which is the best tool to observe the streamline observation. From the right, it's show the beaker contain food coloring dye with control valve, which is to control the flow of dye when enter the test section. Next, this is the experiment condition for lift drag coefficient. Each model will run 5 times for each motor pump frequency. The motor pump frequency which are 25, 30, 40, and 45 Hz. And the angle of attack is 0 degree fixed due to the symmetry cylindrical shape. And then for the experiment condition for streamline pattern visualization, we use only one motor pump frequency at 5 Hz. The reason is to avoid the earlier separation of the dye before it reach the cylinder. And the angle of attack is 0 degree fixed, and each model will be run for 30 seconds for each model. Then we proceed to the result from this project. First, the coefficient of drag for full groove cylinder. The average coefficient of drag will decrease from the beginning effect of the water when reach the groove part. At the 0.1158 meter per second of velocity, the average coefficient of drag will slightly increase not far from the previous value of the average CD as the velocity increase. It shows that cylinders with full groove are effective to lower the coefficient of drag as the velocity increase. Next, we proceed to the second model, half-groove cylinder at 0.085 at 35 millimeter per second of velocity to 0.1002 meter per second of velocity, the value of average CD will decrease linearly. The average CD start to increase until the end of the experiment. Half groove somehow does not much reduce the drag force due to the lower number of groove applied, which is match the previous study. The increased number of groove also increase the number of coefficient of drag. Then we proceed to the smooth cylinder. The graph from figure showed the average CD value will increase start from the beginning water flow rate until the end. As to conclude, the drag coefficient are likely higher at the object that has smooth surface. Then we proceed to the result of coefficient of lift. First, for full groove cylinder at 0.1002 meter per second of velocity, the average CL starting to decrease. The average value of CL are still above the 1 value. Then, for the next model, half groove cylinder, the average CL decrease drastically at the beginning, but then starting to increase slightly near to the 1 value. Then, we proceed to the smooth surface cylinder. The graph pattern will decrease gradually as the velocity will increase. The value of CL show least changing because of the cylinder model was symmetric. The average were going lower than 1 value. So from this graph, as a conclusion, the lift force are not so much affected around the cylinder due to the symmetrical shape. Next, we proceed to the result for streamline pattern for full groove cylinder. For the first 10 seconds, the die start to separate a little as soon as it reach the groove part, and then at the rear side it show unsteady circulation pattern. After 20 seconds runs, it shows the symmetry pattern. The die flow both above and below side through the cylinder center. Circulation pattern at the rear side of cylinder has become higher. Then, for the next model half groove cylinder, for the first 8 seconds, it shows the same pattern as the previous model full groove cylinder. The circulation pattern occur late than the previous model at the rear side. Then, after 15 seconds, it shows the symmetry pattern also. The circulation pattern at the rear side of the cylinder occur due to no groove. Then for the smooth surface cylinder, it shows the flow has thickness because of no groove part occur at the area. And also a late circulation pattern occur at the rear side of the cylinder. After 10 second runs, it shows the symmetry pattern. The flow passing through above and below of the cylinder. But somehow at the rear side, the flow of dye seems stops due to the lower pressure at the rear side. As a summary, I determine the value of coefficient of drag and lift for cylinder with full groove, half groove, and smooth surface. And I'll also determine to get the visualization of the streamline pattern around the cylinder with full groove, half groove, and smooth surface. And then I also able to make comparison of cylinder with groove and smooth surface cylinder. As a conclusion, the application of groove are the best method for drag reduction. Streamline pattern observation around cylinder are not so different because shape of cylinder is symmetrical. The value of lift coefficient are not so much different because the shape of cylinder is symmetrical. For the recommendation, to conduct the experiment with the same parameter by using wind tunnel machine. Use several different type of groove. I recommended use U groove and also V groove. As in this experiment, I use rectangular groove. And then for the last recommendation is to provide a better dye injection setup to prevent the early separation when run in high motor pump frequency. That's all from me. Thank you.